Good to all of you. Welcome back to the class. Today I will discuss about design example of continuous to a slab, and the condition is restraint. Restraints mean the beam and the slab is concreted monolithically or concreted at the same time. So, okay, based on example 2.4 from your module, okay, I already prepared okay, just like this one. Okay, just like this one. Okay, let's say we have the void. Okay, the part of the void here is we change to S number 6. Okay, we have slab here. We have slab. Okay, and then the S1. We will do for S1. Okay, so for the first time, let me okay the dimension. Okay, dimension of the slab is Ly is equal to 4,500 mm. Okay, and this is remain constant as 4,000 mm. Okay, so we will design the slab panel of S1. So let's say this is the section XX, and this one is sorry, X and Y. So this is Y, what direction X? It's okay lah. Let's say this is the section number 1. Okay, 1 1, and this is section 2 2. Okay. Okay, so we will design as number 1, slab number 1. So we will have the bending. Okay, which cases here for slab number 1? Which cases?
4.
Case number 4. Okay, we refer back. Oh, saya tak. Okay, okay, here we refer here. Okay, case number 4, because this slide is I cannot see the value clearly. Okay, case number 4. Thank you, because okay, this is the case of two adjacent edges discontinuous. Okay, so we will refer to this table for the coefficient of bending moment. Okay, so the case is case number 4, because this is discontinuous. This is also discontinuous, and you have continuous here, continuous to the slab number 2, and this continuous to the slab number 6. And then of course we will have the bending moment. Okay, this one MSX. Okay, MSX1 is at the bottom of the span, and then you have let's say purple color. Okay, for the longer direction is MSY, is MSY1, and then you have a bending moment. Let's say orange color here. This one bending moment here is MSY2. Okay, and then bending moment here is let's say here this color lah. Okay, this bending moment is MSX2. Okay, because this one here no bending moment here, moment is 0. Here also moment is 0. Okay, we assume that the bending moment there is 0, so it will be like this one. Okay, this one. Okay, the bending moment okay, because later the reinforcement will be at the bottom and then at the top here. Here, the reinforcement here at the edge. Okay, here we will provide the also reinforcement here as the secondary reinforcement. Okay, and make sure that the AS is greater than AS minimum. Okay, so this is the situations. Okay, let me give you another data. Okay, other than LX and LY. Okay, let me do it here. It's okay. You can refer your module and refer the video later for clearer Vision. What happened ah? I cannot use this one. Sorry. What happened to my pen ah? Okay lah, close and open again. Okay, thank you. Okay, so the situation is here. Okay, the Ly is equals to 5.5 meter. The Lx is equal to 4.0 meter. The Fck is equal to 30 Newton per millimeter square. The Fyk is equal to 500 Newton per millimeter square. The HF is given as 150 millimeter. The C nominal is given as 30 millimeter. And then the GK exclude, okay, the GK without the safe weight is given as 1.5 kilonewton per meter square. The QK equal to 4.0 kilonewton per meter square. And then the diameter of the bar, I want you to try as 12 mm. And then the concrete density is equal to 25 kilonewton per meter cube. So as the solution, as usual, okay, we have to determine the action and analysis. Okay, how about this first, the safe weight of slab? Okay, which is equal to HF times the density of concrete equal to 0.15 times 25. So the answer is equal to
3.75.
okay, good. 3.75 kilonewton per meter square. And then you have a permanent GK equal to 1.5 kilonewton per meter square. So total is equal to total GK equal to
5.25.
okay, good. Thank you. 5.25 kilonewton per meter square. And then the variable load, variable action QK is given as 4.0 kilonewton per meter square. So the design action, okay, we can simplify it. Okay, you don't have to waste your time. So design action for every 1 meter width. So you don't have, we save our time here. And D is equal to, okay, and D is equal to 1.0 multiplied by 1.35 GK plus 1.5 QK. So equal to 1.0 multiplied by 1.35 times 5.25 plus 1.5 multiplied by 4. So any answer now? Anybody have the answer?
13.09.
Okay, 13.09, so make it as 13.1 kilonewton per meter. Okay, unit is per meter because you already multiply by 1 meter. Okay, so we save the time there. So the Ly over Lx is equal to 5.5 divided by 4, so equal to 1.38,
1.4.
1.38. So you can use refer to 1.4. Okay, and then so the coefficient of bending moment ms beta s bending moment lah situ. Okay, so the short span msx1. Okay, this is for bottom. So you refer to this table. Okay, refer to this table and give me the answer. Okay. Sorry. Refer to this table lah. Yeah. Okay, case number 4. So 1.4. Okay, you refer to this table. Case number 4 here. Case number 4 and 1.4. So what is the value for mx1? msx1. Okay, this one. Okay. Case number 4 is here. Case number 4 and 1.4, you refer to this and then here. So these two value, this is for short span coefficient. Okay. So msx1 is equal to which value? Which value, class? msx1. The top or bottom? Positive or negative? Okay.
Positive.
Okay, good. Positive moment. Okay, you will refer to 0.055 because this is for mid span. Okay, mid span. So this one, and then MSX2 is for support. The value is 0.074. Okay, this is for support. Okay, and then similar you go for the long span. For long span, MSY1 and MSY2. Okay. So which value to refer? Here, okay. Which value to refer for MSY1? This one. Okay, only one value for long span. Okay, value for all values of Ly over Lx. So MSY1, which is the value?
0.034.
Okay, good. 0.034. This is for mid span. And then 0.045 for the support. Okay. So okay, simple. Sorry, I have to back to the question. Okay, here is the question, and this is I jump to the detail. Okay, I want to show you the detail. Okay, how to detail this one. This is very important. Okay, later. Okay, which reinforcement? Okay, let's say this is section 1.1 tadi kan? Section 1.1. Okay, section 2.2 nanti kita buat. Okay, so Moment at midspan. Moment at let's say short span. Okay, for this one. Okay. MSX1, okay, which is for the middle, equal to beta SX1 times N times LX to the power of 2 equal to 0.055 times 13.1 times 4 to the power of 2. So what is the answer? Any answer, please?
11.53.
Okay, good. 11.5 kilonewton meter. Okay, thank you. And then the MSX2, which is for the this is for the midspan. Okay, B beta SX2 times N times LX square. So equal to 0.074 times 13.1 times 4 to the power of 2. So equal to, okay, this is for long span. Okay, while you are using your calculator, MSY1 equal to beta SY1 times N times LX to the power of 2. Okay, any answer for this one, for MSY? MSX2. Any answer? Okay, good. 15.5 kilonewton meter. And then how about this one? MSY1. Okay, any answer?
7.1.
Okay, good. 7.1 kilonewton meter. And then the second one is, the last one is 0.045 times 13.1 times 4 to the power of 2. So equal to 7.1 ke atas ni. Oh yelah. This is sebalik saya punya ni. 0.034. Okay, this one is 0.034. Kan? When the moment here is 0. Okay, SY. Okay, betul. 0. This one ni. Betul tak ni? SY1 ni. SY1 0.034 lah. Okay, 0.034. Sorry, this one salah. Okay, this one is 0.034. Okay, 0. Ni betul lah. 0.045. So, how about the answer here? Apa jawapan kat sini?
7.1. Kat situ
7.1.
7.1.
7.1 kan? SY1 0.034. Betul tak tadi? 0.034. So, inilah. Okay. Okay. So, 7.1 here. Okay, this one dah betul. 7.1 kilonewton meter. So, how about this one? MSY2?
9.4. Yep.
9.4 kilonewton meter. Okay. So, you have to design one by one now. Okay. Actually, in the practice, you just have to select the maximum one. Okay. You just have to select the maximum one. So this one, you select this maximum one, and then you apply to all of this one. Okay. So main reinforcement we have a similar spacing. So dekat side kamu pun tak pening, kan? Kamu tak pening nak arahkan pekerja kamu pasang berapa mm, tak pening. This is theoretical. Theoretically, yes, you have to calculate one by one. But in practice, you can select the maximum one, and then you can design so you have a similar design of similar spacing of reinforcement. Of course, you use similar size, so you can have similar spacing, so it will be easier for the contractor to give direction to the workers, and easier to monitor and to do the checking. Okay, except for the secondary reinforcement, we can do for larger spacing of reinforcement, but theoretically you have to calculate one by one. Okay, it's okay. So this one is the design of main reinforcement. So number one, so we have to determine the effective depth as usual. Okay, dx is equal to hf minus c nominal, as I explained in last sessions. Okay, so 150 30 12.2. So what is the value now here? dy is equal to hf minus c nominal minus diameter over 4 over 2, 150 minus 30 minus 12 over 2. So what is the value of dx and dy? Any answer?
114 mm.
X 114.
Sorry, 114 mm. Okay, good. And then dy?
102.
Okay, thank you. Okay, and then you as usual, as minimum and as maximum. Okay, let's familiar ourselves with this one, because you must can score mark here. Okay, 0.26 FCTM times B times D over FYK greater than equal to 0.0013 BD equal to 0.26 2.9 1000 114 divided by 500 0.0013 1000 times 114. Okay, what is the answer? This one is 1. One hundred and
172.
okay, 172 mm square, and then greater than 148 mm square. You use as minimum equal to 172 mm square. So the as maximum, you can use 0.04 AC, which is equal to, you can directly go 0.04 1000 times 150. Okay, don't waste your time to write down all the equations. Okay, what is the answer now here?
6,000.
Okay, 6,000 millimeter square. Thank you. Okay. So the third step is short span at the mid span. Okay, middle of the mid. Okay, which is the BB, bottom of bottom. And then the bending moment MSX1 is equal to 11.5 kilonewton meter. So you can calculate the value of K, which is equal to 11.5. I don't have to write down the equation, okay? 30 plus times 1000 times 114 square. In the exam, if you are familiar with the equation, it's okay. You can just insert the value. I will consider for you. Okay, I don't want you to waste your time. Okay, what is the answer here? Z is equal to 0.5 D 0.5 minus plus 0.25 minus. Okay, berapa jawapan K sini? What is the value of K? 0.029
029.
lesser than 0.167. So conclude as singly reinforced. Okay, so 0.029. Okay, what is the value here of Z? 0.97 D kan? So you use 0.95 D. So the AS required is equal to 11.5 times 10 to the power of 6 divided by 0.87 times 500 times 0.95 times 114. So equal to
244.
okay, 244, thank you, 244 millimeter square per meter. So you provide, okay, let's provide the maximum, let's say 1000 divide, you can refer to the table, okay, and then you times the AS 113, okay, the area of steel, this is for 4H12, equal to, okay, I hope you still can remember what I'm trying to do. It's okay, during the final exam, I will provide you the table, okay, until 400 mm or 450 mm for secondary bar. Okay. Okay, this is H12 400 AS equal to as provided is equal to, okay, 283 mm square per meter. Okay, this is mm center to center. Okay, this is one answer. Okay, this is the answer for MSY. So this one, number one here is let's say a green color. Here this is the steel bar. This is the steel bar here. Okay, and then this is the spacing from here to here. Okay, and then you buat color, buat bulat sikit sini, and then you mark as 01. So your 01 now is H12 400 BB, bottom and bottom. Okay, so this one yang color hijau. Color hijau adalah yang this one. Okay, the green color, this one, the bottom part. Okay, so at the until the end lah. Okay, the green color, the reinforcement. Okay. Okay, and then mid span and then short span. For okay, short span at support, the MSX2 is equal to apa ni? 15 15.5 kilonewton meter. So the K is equal to 15.5 divided by 30 times 1000 times the K is still 114 square. Okay, you can get me, please get me the value. Z is equal to D 0.5 plus 0.25 minus k and 1.134. So what is the value of k here? Of course, it will be greater than lesser than 0.167. So singly reinforcement. So what is the value? 0.040. 0.04. Okay, so you just use 0.04 here. Okay, what is the value of Z?
0.96.
Okay, so this one is 0.96 D. So you use 0.95 D. Okay, so you calculate the S required. 0.95 times 114. So equal to, okay, what is the S required?
Oh, 329.
329. Okay, good. 329 millimeter square per meter. Okay, so you provide H12 at berapa? Dia center, center to center. Check ni ya, check kita punya alamat. Okay, check this table. Okay, focus to H12 at the bottom here. 300, so we can get 377. Okay, 377. H12 300 mm center to center, so AS provided is equal to 377 millimeters square per meter. Okay, and then so here at support. Okay, at support, so means this one. Okay, number. Okay, the reinforcement. Okay, let's say red in color. So this one at support. Okay, this one. Sorry, because the bending moment is here. Bending moment is here. This is MSX2. This one is MSX1. So the here. Okay, red color here. At support. Okay. Okay, from here to here. Okay, so number is number 2. The number is 2 here. So number 2 is H12 300 top. Okay. So, okay, kita nampak kat sini sebab kita tak cut session ni nanti. Okay. Okay, and then what else? MS. Okay, long. Okay, we go for the long span. Long span. Okay, for mid span. Semua boleh buat ya. Saya tak nak ada tertinggal ni. This is very important. Long span. So this one. Okay, for MSY1. Okay, long span. Okay, the bending moment is equal to MSY1 equal to 9, berapa tadi bending moment dia? 7.1 kan? (7.1 kilonewton meter). Okay, let me check first. Okay, 7.1. Okay, MSY1. Okay. So the value of K is equal to 7.1 times 10 to the power of 6 divided by 30 times 1000, the B times the 102. Okay, be careful about the D. Now the D is referred to dy. Okay, so what is the value of K? Okay, lesser than 0.167. So this is singly reinforced. Okay, please calculate to me. Okay, berapa value ni? What is the value of K?
0.022.
Okay, 23. Okay, thank you. 0.023. Okay, equal to berapa D? Kita ni let's say 0.98D. Okay, so you use, usually for slab, we use 0.95D. Okay, so the AS required is equal to 7.1 times 10 to the power of 6 divided by 0.87 times 500 times 0.95 times 102. Be careful here. Okay, your D. Okay, what's the value?
168.
168 millimeter square per meter. So this one we better provide the maximum millimeter center to center. So AS provided is equal to, just like the midspan of this one, 28283. Okay. Okay. So next, okay, so this one for the detailing, let's say I'm using color, okay. Okay, the direction is long directions. So let's say this one, okay. Here is this is the steel bar that you will install on site. Okay, for every 400 mm. So this is how to simplify your drawing. Okay, and then you numbering as number 03, and the detail here is 03 equal to H12 400 bottom but top. Okay, bottom top. So this one, this is the meaning of bottom and top. Okay. Okay. For section 2.2, you try to do by your own. Okay, section 2.2 is here. Let's say section 2.2 is you cut from here to here, and then try to provide section 2.2 by your own. Okay, which one is at the top and which one is at the bottom. Okay, let's proceed with the long span. Still long span, but now is at the support. So where MSY2 is equal to 9.4 kilonewton meter. So K is equal to 9.4 plus 102 square. So what is the value of K? 7. So singly reinforced. Our Z is equal to D. Okay, what is the value? Can I get the value of K?
0.03.
0.0. Sorry,
0.03.
3, yeah? Okay, 0.03. Okay, what is the answer here?
0.97D.
7D, so you use 0.95D. Okay, thank you. And then AS required is equal to 9.4 times 10 to the power of 10 divided by simplified your, okay, times 0.95 times 102. So what is AS required?
223.
2,
223.
223. Okay. So just similar. So we provide H12 at 400 mm. Center to center, you can get AS provided to 283 mm square per meter. Okay, so this one the support. So this one, okay, let's say I use orange color. This one. This one support. Okay. Oh here this one. Okay, at the top. Okay. And then okay, this is the how to do the detailing. So this one. Okay, make it here. Make a dot. Just make a simple dot and then label by number 4. Okay, and then you can have the notes. Sudah. This one number 4 is H10, H12, 400. Okay, TT also. Okay. Okay. So it will be simple. This is 300. Okay, 300. It will be simple. You choose the maximum one, the critical one, and then you use 1, 2, 3 as H12 300. Okay, easy to design, but if you want the economical design, you have to recalculate. Okay, you have to redesign to get the more economical design. If the client asks you to reduce the cost, so this is how to play. Okay, you can reduce the cost. If the client agree with the cost, so just proceed. Okay, so now you provide the secondary bar. You provide the secondary bar. This one. Okay, step number 5. Good. Secondary bar. You try provide H12 450 mm center to center. So you can get as provided is equal to 1000 divided by 450 times 113 sama dengan berapa? Sama dengan
283.
283 kan? 283 ya. Sorry, 283 ke 251? This is
51.
450 lah. Okay.
Oh, 251.
251 mm square. So it is still larger than the AS minimum because our AS minimum is here. Okay, AS minimum is 172. So we can provide maximum. Okay, at maximum greater than AS minimum. So okay, so here we provide at the support. We provide, let's say here, I use the at the bottom, okay, at near the support. Actually, we put it near the support. Silah ya violet lah. Here, okay, this one. Okay, so this is the reinforcement here, and then dia melintang kat sini. Sini pun, okay. Secondary bar because the bending moment is 0 there. Bending moment is 0, but we have to provide minimum as secondary bar. So this is okay for secondary bar. Okay, 0.5. Okay, so this one 0.5 along this one. Okay, secondary bar, and then this is also secondary bar. Okay, near the support. Here also secondary bar. Okay, or we call it as a transverse reinforcement. Okay, so this one is also 0.5. Oh, sorry, color different color. Okay, fine. So you can try to do the section of 2 and then you you try to locate the reinforcement letter. Okay, this is also 0.5. This one also 0.5. Okay, because the bending moment here is 0 moment, but we have to provide the maximum, the minimum. This one also you have to provide as the transverse reinforcement. Okay, if you still okay. Okay, any questions? So you can do the notes here. Page 12, 450. Top by bottom. Okay. Okay, class, any questions about this design? And then the next step is, as usual, you have to check shear reinforcement. Okay, the requirement for shear reinforcement. This one you have to refer to this. Okay, you refer to the module for the shear reinforcement here. You can see here that okay, the writer calculated, prepared the calculation for all short span and the long span here. Okay, short span and long span. Okay, but in order to reduce your time, save your time, you can open to the, in order to save the time, you select the maximum one. Okay, you select the maximum one, which is his. Okay, the n is similar, the lx is similar, so the coefficient, the beta v, you select the maximum. You select the maximum and then you calculate for VED, and then you can calculate proceed with the calculation of VRDC, which require you to calculate the K, the P1, and so on. So you select the maximum, which direction of the maximum. So in this case is VX1. So you can get the value of coefficient from this table. Okay. Okay, from this table, this is from this page, page 98 of your module. Okay, this is the shear force coefficient. Page 97 is bending moment coefficient. Please don't confuse. Okay, so BVX. So the case is case number 4. Okay, so you select this one. Okay, this case number 4. 1.4 is our case. So and then the case number 4. So this one and this one. So you select the maximum coefficient. So in this case, this is our maximum coefficient, which is beta Vx1. Okay, beta Vx1. So you select, okay, beta Vx1 is equal to 0.52. 0.52. So you can calculate by using this equation. Sorry, you can calculate this one. Okay, beta sama je equation dia. You use this equation, but the Lx is not the square one. Okay, so VED is equal to Vsx1 is equal to beta Vx1 times n times Lx. So equal to 0.52 times 13.1 times 4, and then you got the answer of VED, and then you can as usual check the VRDC, and then you compare to the minimum, and then you compare to the VED. So the answer is for slab, usually the VRDC is greater than VED, so we no need shear reinforcement. So we don't need the shear reinforcement there. Okay. And then you check for deflection. You check for the X direction only. Okay. Check for you can try both. Okay. You can try both. The for both x and y direction, make sure you use corresponding dx and dy. And okay, because okay, and then the lx here for the lx or ly. You can check okay for both direction of the deflection. And then you can check the cracking. Make sure for the main bar it not exceed 400 mm. For the secondary bar it not exceed 450 mm. And then proceed with the detailing like this one. Okay, any question? Any question? Okay, I hope you can proceed. As usual, you can proceed with the checking of shear reinforcement. Okay, this is the tips I give to you, and then check the deflection, and then E is you check the cracking. Okay, this is the steps, and then okay, so bersempena raya ni, this is the duit raya I give you. This exercise number 17A. Okay, exercise 17A is you repeat, just repeat exercise 17, but change the change the FCK is equal to 25 Newton per millimeter square. And then you change the C nominal to 25 mm, and you change the diameter to 10 mm. Okay, then you try to compare the answer. Okay, and then dengan rahmat dan kasih sayangnya juga, saya nak bagi exercise number 8, exercise 17B. Okay, use similar situation as exercise 17, but change the location, change the position of slab. Okay, you do the, let's say this one saya lukiskan sikit lah ya, similar situation means similar loading, similar grade of concrete and so on, but you use saya nak you buat kat sini. Okay, let's say we have the slab here. Okay, similar lah, saya rasa similar je kot. So dia this is ly. Sorry, I not draw it according to scale. Sorry, I have to redraw. Better redraw. Malu je. Okay, so this is the beam, the slab. Tak sama juga ya. Tak apalah. So ly tu sama je. Okay, you assume sama je. Ly is equal to 5,500 millimeter, and Lx is equal to 4,000 millimeter. Okay, so however here you have void here. Okay, this is S1 yang kita buat tadi. This is S2, S3, S4, S5. Sorry, S5, S6, S7, and S9. So why not you try the here? You try here lah. Okay, do this slab panel. Okay, and this one is void. Okay. Okay, you try to do the slab panel. Let's say the The cross section is this one. Cross section 1, 1. Okay, you do for cross section 1, 1. Okay, set. Okay, find detail for section 1, 1. Okay, you buat yang itu. Okay, and then dengan rahmat kurnia yang maha kuasa, bersempena dengan Aidilfitri yang mulia, saya menganugerahkan exercise 17C where you have to repeat. Okay, sementara menunggu saudara yang datang, repeat exercise 17B for okay, Vignesh. Vignesh boleh buat ni kan? FCK is equal to 25 Newton per millimeter square. C norm is equal to 25 mm and diameter is equal to 10 mm. Okay, so this is your duit raya from me. Okay, a total of 4 exercises. Okay, we already did half for today. But you have to complete the checking for shear reinforcement, check the deflection, and check the crack. And then this is for your Hari Raya number 1, Hari Raya number 1, Hari Raya number 2, and Hari Raya number 3. Okay. It's okay. I will share this one in the drive later. Okay, this is your. Okay, boleh faham ya semua?
Oh, boleh tak tu?
Boleh, alhamdulillah dengan senang hati. Okay, sambil-sambil nak tunggu lemam masak kan, dia boleh buat kejap. Okay. Okay, boleh ya. Saya nak ni. Okay, any question class? Lebih 1 jam kita bersambung siaran. Okay, thank you so much for your cooperations.